This is going to be the laser emulation for a probe. So we know that the probe line and beam is what we call it. The probe beam is very, very thin, paper thin. So the beam we know is flat and paper thin. And it's straight. It doesn't curve or bend. It's completely straight. And we know that if it reflects at a specific angle, it's going to go to a different direction. However, to be able to read, remember, this is not just a energy delivering device or signal delivering device. It's also a sensor that receives it. It needs the energy and signal sent from the probe to come back to the sensor. So it needs to hit an object and come back up for us to be able to see and interpret the image. However, if we are angled at the incorrect angle, then it will not go back to the sensor. So we need whatever we're doing to receive it, the energy to receive back into the sensor, and we're going to demonstrate that with the laser. What I would like you to do is we have 5 lasers and 5 boxes. These boxes are to simulate the flat surface of a probe, okay? And there will be a hole in each one of them, and they're going to be measured out and cut to match the hole in the box with the laser. So what I would laser and match the hole so that you do not see the light illuminating the box. If the light is illuminating the box, then it's not positioned correctly. It must not illuminate the box. So from here, I'm going to carefully close this box and lock it in place. Now, I have a working laser probe. This full covered mirror vein simulator is going to pretend to be a vein. So we're going to put this down here flat. And what I want you guys to simulate is when the box is lit up, that means the laser is hitting the sensor of the probe, just like this. Okay, let's pretend this is the probe. Now what happens if we angle it at an inappropriate or the wrong angle? The box will not be lit up because the laser is moving in a different direction. So this is the concept. When the box is lit up, there's enough of the energy hitting the sensor of the probe, the sensor of the box, and this is going to let us know that we have the right angle. There's another piece to this I want you to use. Okay, so with these fogs, you can see the laser beam and exactly where it's going. So I have a little fog machine and I'll give you instructions when I get there. Next video I send you, you guys will have instructions. However, a little bit of fog, you can see the beam of the laser, and this is also the same beam of the probe. It behaves the same way. So I want people to understand that. You can see how the beam is moving and now hitting the sensor back. It's the same idea. Now what happens when that probe is angled too much? It gets further and further away from the probe sensor. And so what I want you guys to teach them is that the angle of your probe makes a big difference. So this is a vein. The vein goes up and down, usually pretty straight with a little bit of a curvature. However, it's pretty much parallel to the arm. And so we need this to be at a 90-degree angle for the vein. However, we're not looking for the vein anymore. We are looking for the needle. When we are inserting the needle, we need to guide the needle back down and follow the needle. But if we're having a hard time seeing the needle, we don't know if we're here or here or here because that laser beam is going this way and it's not going back to the probe. So for it to go back to the probe, for the energy to go back to the probe, we need to angle the probe so that the beam comes back to the sensor. Okay? So that's what we want. And so I need you to show and teach these clinicians to change their angle, and they will be able to see the needle much better. However, when this happens, what happens to the visualization of the vein? Now we won't be able to see the vein very well. And so it's a bit of a compromise. So we try to meet in the middle and figure out a good compromise that'll get us as close to having to be able to see both at the same time. Okay. Another thing I want you to teach them is, yes, you may angle the probe, but at what point, and we found the tip right there. What I want you guys to show them is, even though this is the anatomical position of the vein that you want to attack, I want you to try to attack the vein at this target, at that dot right there. That means we need to guide the needle down to the surface. And what I want you to show them is the step-by-step movement of finding the tip. How do you know you found the tip? When the visualization of the needle tip disappears. You've got confirmation. Okay, here's the needle, here's the needle, here's the needle, here's the needle, here's the needle. Boom, needle disappeared. The laser or the beam is not hitting our sensor. So now I know I've passed the needle. I need to go back, and this is my tip. Bright, no bright, bright, no bright. This is going to let them be able to see that this is the needle tip. When the needle disappears on the image is where their needle tip is going to be. And now they move forward, move the laser, move the needle, move the probe, move the needle, move the probe, move the needle, move the probe. And now they can slowly walk their needle down to the right point instead of guessing. Because a lot of times what people do is that they're like, ooh, I found the needle tip, good. And then, but they're not at the tip. They think they are, but they're actually highlighting the shaft. And they keep going, and they've already punctured through and through the vein, and they're wondering why it didn't work. It's because they did not follow their tip correctly. Okay? So I want you to show them that. Another thing, when they visualize the needle perfectly by getting the sensor beam back, or the beam back to the sensor, when we're looking for the tip, we also have to realize that we need to slide the probe to the tip at this angle. And then we need to continue to move it down. So this is the exercise I want you guys to show. Using the laser, we're going to show the importance of angle, why the needle guides are bad for you. I recommend do not use those. Those are handicaps. Even for beginners, it does not help you because it trains you with poor habits. Using the lasers and the mirrors to show how tissue and needle reflects the beam of the ultrasound back to the sensor. So we're going to have this for you guys to play around with and teach them.